Okay, so we're still on factoring quadratic expressions on the first day of 5.3. Before we get to the equations, next class will be dealing with things with equal signs and finding solutions. So we're still just factoring here, and we've made it to the back side of the page. These are the more challenging ones. There are so these are called, I'll just call these level 3 for no reason. I just made that up. But I wanted to indicate, like, that these things get harder. So this one's a little bit more challenging, and I can tell kind of right off the bat it's going to be more challenging because A is not 1. All right, let me zoom in just a little bit. Maybe. Not really responsive today. What's going on? Okay, there we go. Okay, so here my A value is a 2, not a 1. I'm going to try pencil here in case I make mistakes. It's a bit more forgiving. This is my only copy of this worksheet, so I don't want to mess it up. All right, so we have actually 2 methods here, right? So guess and check method or the algorithm. And in the book, if you look at the examples in your book, I believe that they use the algorithm method. Okay, so let's go ahead and, like we did with the last one, let's go ahead and work backwards so you can see why this is a bit more complicated. So here's the answer. I already gave it to you. But let's go ahead and do the multiplying steps, and then we can kind of see where the tricky stuff is as we work backwards to factor. All right, so here's the answer. And this answer comes about by multiplying 2x times x, 2x squared, 2x times a negative 5, which is negative 10x, and then 3 times x, which is 3x, positive 3x, and 3 times a negative 5, which is negative 15. All right, so that's the double distributive property. The last thing I would do here is combine like terms, 2x squared minus 7x minus 15. Okay, so that is the answer. I kind of jumped ahead. Here's the answer, and this is how I would check it. And notice this trinomial expression, quadratic, is the same as this factoring problem. All right, so here's the answer. And the tricky thing comes in this combining of like terms. There are a lot of ways to create this middle term x, so that's the trickiest part. But let's go ahead and go with what I do know. So I'm just going to go in order here. There's 2 methods. I don't want you just to jump onto the first one because it's the first one I show you. I've had a lot of students in the past feel really comfortable with this algorithm method. So let's just see. I'll show you both and then practice them both and then see which one you're most comfortable with. And then you can sort of rely on that. But don't just jump on the first one because it's the first one I show you. All right. So what I know, right? If I have, well, first I'm going to try to steal. Remember, always steal first if you can and whenever possible. I don't have a greatest common factor here besides just a 1, right? So there's nothing I can steal from all 3 of these terms, right? So I can't steal. So I'm stuck with a trinomial where a does not equal 1, right? A equals 2. All right, so I have an idea about my structure. I know it's going to look like this if it's factorable. 2 binomials. I also know that to get an x squared, my first piece of each binomial is going to have an x times an x, right? So I know this basic structure. I don't know what the coefficients are if they have them here, and I don't know what the constant terms are. Okay, but I do have a lot of clues. All right, so first of all, notice where the 2x squared comes from in my answer, right? The 2x squared comes from multiplying these 2 pieces. So what 2 things could I multiply to get 2 for these first 2 pieces? The only factors, so I'm going to make a list here. The factors of 2 are 2 and 1. I'm not going to worry about double negatives here for the first term, but I do have to worry about that here. So I'm just going to keep these positive. 2 times 1 is the only thing that could make 2x squared. So I know actually now that this must be the case. And I'll write the 1 in here, but you don't have to. I'm just going to I'll make the invisible visible. So I have a 2x times x. Okay. So I definitely got that. But Now this back piece, right, to get this constant term of a negative 15, so here's my other kind of place where I'm looking for clues. To get a negative 15, I have a few more options. I have 15 and negative 1, negative 15 and positive 1. I have 5 and negative 3 to make negative 15, and negative 5 and a positive 3. So these are my only 4 pairs of factors that could give me a negative 15. So this is called the guess and check method because you get your list of clues and then you create your guesses, right? So I'm just going to go ahead and write some of them out, and we'll see. We'll just see how it goes. All right, so it could be a 15 or a negative 1. It could be I could also switch the location of these two. It could be in the other order, a negative 1 and positive 15. So I'm making a list of guesses here. Here's a couple over here as well. This could be a 2x plus 5 and an x minus 3. Or I could have a 2x minus 3 and an x plus 5. Right, so these are 4 out of really the 8 options. So which of these gets me really close to this? So to recap here, we know that the first 2 are good. We know that the first 2 pieces here, the 2x and the x, will give us a 2x squared. We also know that the constant is going to be fine because in each case, when I multiply the constants, I get a negative 15. What I don't know is this middle part. This is the tougher part. So this middle term comes from when I multiply the inside parts and the outside parts, right? This is where the middle comes from. It's from this inside-outside piece. So you can actually just multiply these out and see which one works. It's the checking part that we've been checking all along. But I'm going to go ahead and speed it up a little bit. I'm going to say, okay, I know the first and the last terms are good, but when I multiply the inside, I get a positive 15x. When I multiply the outside, I get a negative 2x. And when I combine these, do I get a negative 7x? No. Right, this one would give me a 13x. So this one is no good. When I multiply the insides here, I get a negative x. When I multiply the outsides here, I get 30x positive. That also does not equal what I'm looking for. Let's try these. 5 times x on the inside is 5x, and on the outside, I have negative 6x. That would give me a negative x, so that's also not good. And then here I have negative 3x and a positive 10x. When I get these, add these middle terms, I get positive 7x. So that is pretty awesome, but not the right answer. Notice this is positive, and I wanted a negative 7x. So this is awesome. I just need to switch the sign. Make this, instead of a positive 7x, I needed it to be a negative 7x. So when you get to that, if you get to that stage, you get really close, but you don't get the answer, try switching the 2 signs here. So I have 2x plus 3 and x minus 5. Right? That's still on my list of factors. And now when I check it, I'll get 3x on the inside and negative 10x on the outside. So this is my answer. If I were to multiply this out, I'd get 2x squared. The middle term here, the b term, would be a negative 7x, which is what I wanted. And I already knew the outside was going to work, that last constant term. So 3 times negative 5 is negative 15. Okay, so that's my answer. I did it. There's kind of a lot there. And as you practice it, you'll get better and better and better. I don't really have, let me just see if I can get another piece of paper. I don't have enough room to show you the second method. I'm just going to grab some scratch paper here. You may need more room on your page as well. So here's the problem: 2x squared minus 7x minus 15. And I'm going to show you the algorithm method this time. Okay, so that was guess and check. You have a bunch of guesses, educated guesses, not random, based on your factors of A and C. Create a list, check each one until you find the right one. And as you practice this, some students will be able to do this in their head, not necessary. Just make sure you're double checking and getting the right answer. Again, a sign error means you can really throw things off by just making it a sign error. So you have to be pretty deliberate and careful. Don't be tempted to skip steps to speed this up if you're not able to get the right answers regularly. All right, so I'm going to go ahead and look at the next one, or the same problem, but with the algorithm method. All right, so this is I'll show you the steps. First, you multiply A times C. First, multiply A times C. 2 times negative 15 is negative 30. And then we will list factors of that product that we just got, of AC. So I have negative 30. So I could have negative 30 and 1, 30 and negative 1, negative 15 and 2, 15 and negative 2. This is kind of a longer one. 10 and 3, could be positive or negative, or 6 and 5. These could be alternating positive or negative. So it's quite a list, and there's actually 2 here and 2 here. Which of these add up to B? Similar to when A equals 1, right? So which of these combinations adds up to B? In this case, it looks like it'll be negative 10 and a positive 3. Right, so that's the one. So this one right here. Okay, so this shows me, okay, this is the one I'm going to use. And what I'm going to do is I'm going to take that negative 7x, I'm going to split it to negative 10x and a positive 3x. All right, that's equivalent. I can write it that way. Like that. So I split up that b into what I needed based on this procedure. Now I basically have 2 stealing problems. I'm going to cut this thing in half. I'm going to steal from the front 2 binomials, just these 2. 2 and negative 10, I can steal a 2. X's in both, I can steal an x, and what I'm left with is x minus 5. I'm going to steal from the second 2 terms. There's a 3 in common here. It's a positive 3. And now notice, this same binomial x minus 5 shows up in both. That should always happen in this step, right? Whatever shows up here, whatever the binomial is, excuse me, it has to be in both pieces. So now I can do, I can steal, again, the group. So this is called factoring by grouping. I can steal this group. So I'm going to steal an x minus 5 from each group, and I'm left with 2x plus 3. That is the same answer that I just got with my other method. 2x plus 3 times an x minus 5, 2x plus 3 times an x minus 5. All right, let's try one more. Let's go both methods. All right, so I'm going to start with, first, can I steal? No. These 2 are even, but this one's not. So, yeah, there aren't factors in common here that I could steal. So I still think you should steal first, and whenever possible, but it doesn't work in this situation. So I'm going to go guess and check. I'm going to look at factors of A. So I have 4 and 1, or 2 and 2. Factors of negative 27. Are 27 and 1, plus or minus or plus, and then 9 and 3, plus or minus 9 with a negative or positive 3. As long as the signs alternate, I'll get a negative 27. Okay, so that's going to be quite a bit of options here. Because I have 2 options for A that I didn't have above, it's going to really make a lot of options. So again, I'm going to create a list, and maybe I'll get lucky early on. We'll see how it goes. All right, so I'm going to start with, let me think about this for a minute. Let's just start with the 4 and the 1. I feel confident that the first terms look like this, and then I'm going to take a guess on my second terms. I'm going to skip the 27 and 1, and the reason is that's a pretty big number, 27, and I don't think I can add or subtract some other number to get down to a 12. So I'm going to focus on the smaller one first, and again, it's just guessing, so you don't have to go in order, right? You're just going to make a list and hopefully get to the right one. So I'm going to go ahead and go with, let's see, let's go, let's just go +9 here, and then -3 here. All right, check it. 9x for the middle piece, -12x for the big piece, add them together and I get -3x. Okay, that did not work. That wasn't really even close. I got -3x. All right, so let's see. I could switch it around and put the 3 with the 4x and the 9 with the x term. And then, oh, I don't like this one either. So I have -3x here, but look how big this number is. This is a +36x. Remember, my goal here is b, +12. I'm not feeling good about that either. All right, so I feel like 4 and 1 is not going to be my options for the first two x terms. So I'm going to go ahead and switch to the other group here. I'm going to say 2x and 2x. So that's the other way that I can get 4x squared in my first term. And then I'm going to do the same thing. I'm going to kind of cycle through these options here. And let's go like a +9 and a -3 and just see how that goes. So here I have +18x for my middle term. And combined with -2 times -3 is -6x. Oh, that's awesome. All right, so -18 minus 6 is +12x. So this is the answer. I got it. And you can multiply it all the way out just to really be sure. But I feel really confident. This is my answer here. 2x + 9 and 2x - 3. Remember, the first terms add up to 4x squared. The last constant pieces, when I multiply them together, give me the c of -27. And then my check process up here of the inside terms and outside pieces gave me the +12. So this is it. All my signs worked. Worked out great. Okay, so let's go with method 2 here. Same problem, so I know the answer, but let's just go ahead and try the algorithm. So a times c is our first step. 4 times -27. Oh, this is going to be messy. Let's see, 54 and double that is a -108. Okay, so now I need factors of 108 that add to 12. So I'm going to make a factor list here. I'm going to skip 108 and 1 because that's not going to work. But let's see, it'll be 2 and 54, and it will be, it's divisible by 3 as well, 3 and 32? No. 36. 3 and 36, I don't like that one either. 4 and 227. You see, I'm wanting to add these things to add up to 12. So I'm getting closer. They're getting closer together. But the difference here is still 23. It's still big. Let's go 6 and once, and then 48. Oh, there it is. 18. So these are my factors. And these will add up to 12. If this is positive and this is negative, right? Because it's a -108. This is how I'm going to split up b. So I'm going to go ahead and take my b. I'm going to split it and write it as 6x - 18x. Then I have these other pieces. So I split my b, divide this into two stealing problems. I can take from my first pair here, 2x, and I'm left with x plus 3. These are both negative, so I'm going to steal a negative. Anytime that first term is negative, I'm going to take the negative with it. So I can steal a negative. These are both divisible. This is divisible by 6. Oh, they're both divisible by 3. Oh, there's a big one. They're both divisible by 9. So I'm going to take a 9 from the 18 and the 27. I'm left with an x here, and negative 9 times a positive 3 is negative 27. So it's a stealing problem. Little binomial steal, and then notice these are the same. Have to be the same. So I'm going to go ahead and take that out. I'm going to steal this group, x plus 3, factor by grouping, take them out of each, and then what I'm left with is 2x minus 9. Right? Once I take this, I'm left with 2x minus 9. And this is the same answer, right? Wait, it's not true. What did I do wrong? Oh, right here. When I stole the 2, I was left with a 2x plus 3. When I stole the negative 9, I still had a 2 there. Oops. So when I'm stealing, that's why I used a pencil. All right. There's a reason. Now it's the same. I think that sort of reiterates, right? That wasn't on purpose. I made a mistake. But I do have like these checking methods where I'm double checking stuff. And that double distributive property where you just multiply this out to check is a very important last step to make sure you have the right answer. All right, so here's some you try it. Why don't you give it a shot? I will give you a couple minute head start, and then I don't know about this. Did I do it? Yeah. All right. Try to steal first. That's my advice. Okay, so I'm going to go ahead and go through these kind of quickly, but you can always watch this at home, pause it or whatever, or ask questions in class. Check with your neighbor. All right, so I'm going to try to steal first, always. See, I can steal an x from both of these. They're both divisible by 5. So I'm going to take out a negative 5 and an x, and I'll be left with 3x and negative 20. Check it. It works. There we go. Try to steal first in the next one. They're all even. So I can definitely take out a 2. And is this divisible by 3? I think these are all divisible by 6. 150 divided by 6 is, yeah, that works as well. All right, so I'm gonna steal a 6 from each one of these. You know, let's say I didn't see that. Let's pretend like I didn't see that. I'm not going to assume like it's that easy. So I did see pretty straightforward. These are all even. So I'm going to steal a 2 from each of these. We're left with a 3x squared minus 30x plus 75. And then I'm just going to look again. Divisible by 3 and 1, 3 and 10 and 5 and 6. So this one also has a 3. This one's divisible by 3 as well. So I'm going to steal another 3, another piece. And this is what I'm left with. Nice, so that's how okay, so I have a 6. And then this is kind of interesting. This is actually a better problem for the next set. Steal first, and then sometimes you can factor what's left. This is an a equals 1. Are there things that multiply to c that add to b? So in this case, factors of 25 that add to negative 10 are negative 5 and negative 5. So x minus 5 times x minus 5. Or you can write it as x minus 5 times itself, factored. Okay, last one. I can't steal A is not equal to 1, so these are one of the harder problems like above. I'll go ahead and use the algorithm method, just arbitrarily. Actually, not arbitrarily. I don't have a lot of room on my paper. I'm going to use the algorithm method, but you can use whatever method you prefer. A times C, 5 times negative 12 is negative 60. And so I have like 60 and 1, 30 and 2, 20 and 3 are my factors that I really like. 6 and 10, like 5 and 12. Got all these options. All right, so this is kind of neat. I've got which of these is going to add to a positive 17? Well, since this is a negative 16, my signs have to be opposite. So if I had, because I think these are both kind of enticing. You can tell 20 and 3 you can combine to make a 17. 5 and 12 you could combine to make a 17. So, but which one do we choose, right? So because the signs have to be opposite, right? This is a negative 20 and a positive 3, or it's a positive 20 and a negative 3. These I can combine to get a positive 17. Because the signs have to be opposite, I either have, for this bottom pair, 5 and a negative 12, or a negative 5 and a positive 12. So because the signs must be opposite to multiply to a negative 60, this one's not going to work. I'll either get negative 7 or positive 7. All right, so it looked good on the surface, but when I really looked deeper at the signs which ones have to be positive and negative, this one is not going to work. So I think 20 and negative 3. So I'm going to take this 17x and I'm going to split it into 20x minus 3x. And then I'll bring down my other two terms, my a and my c. And now this is where I factor by grouping. I steal from the front, I steal from the back as sort of two separate stealing problems. 5x times x plus 4. And then I can steal a negative 3 from these two terms. Negative 3 times x plus 4. They both have an x plus 4, so I can take that out. Steal the group, and I'm left with 5x minus 3. All right, so I'll go ahead and leave you to do the last set. This actually is not any harder, so don't worry. It's a combination of methods. So this is actually, right here, a level 4 problem. So we just actually did a level 4 because we stole first and then broke it down from there. So in each one of these, I'll give you a big hint. Steal first and then break it down. So let's turn this into sort of a you try it. Steal first. That's my advice, always. Steal first and whenever you can. And so steal, and then take it from there. So why don't you give it a shot, and then I'll show you the answers. All right, so here are the solutions for the first A, level 4. So I stole the 7. I was left with this binomial where B was 0. So opposites add to 0. Things that multiply to negative 25 and add to 0 are a positive 5 and a negative 5. And so then again, you can check this. Multiply 7 into the first. And then multiply that by the remaining binomial, the double distributive property, and you would find, I think, that it checks out just fine. And on the next one, steal first, always, right? So first I stole 2 because I noticed they were all even, and I was left with this. So this is a problem like the top of the page where the a value is not equal to 1, so it's your choice, algorithm or guess and check. Hopefully you get down to this. This in between, this trinomial that I was left with, gave me this as the answer. So I factored it as far as it'll go. So that's what factoring completely looks like. Essentially, it's steal first, and then whatever you're left with, apply the appropriate method. These last two bits are the most challenging. So I think you need to, as far as practice goes, definitely start off by getting comfortable with the first couple styles, and then many of you will need to look for and find odd numbered problems to practice this skill. once you get it, it really starts to make sense, but do expect to struggle through some of these, ask a lot of questions, and try to find that really specific point of confusion, like the step that you're getting stuck with. It might be the first one, or it might be somewhere in the middle. But wherever it is, try to identify it and work through it with the help of people that can help you and are willing and getting the right answers, right? So good luck, work hard at it, and then I expect to get some questions when I get back.